we're using a new one, not the file that...
Yeah, there was one to download. Don't worry about downloading that file. We'll start with a new one. In fact, I think the algorithm, that was supposed to kind of visualize the algorithm that we're going to implement, but I think the algorithm's not quite right, so we'll go read the algorithm off of Wikipedia when we get to it. But before we do that, I have to understand the context of the example that we're going to do today. So imagine, I know it's tough for you to imagine the 1970s because most of you weren't born, but imagine the 1970s. In fact, is there anyone here besides me who was born in the 1970s? Yeah. So, imagine that, you're working at a bank and you think, I think these computers might just catch on. Maybe we should use computers. In fact, in the 1950s, did you know this? IBM estimated the total worldwide demand for computing devices. They called them computers. You know what they estimated in the 1950s? Say it?
7.
It's actually like 5. Anyway, it's some kind of crazy.
I'm optimistic.
There are some of you that have 5 computers that you carry around with you all the time. You've got a watch, you've got a calculator, you've got a phone, and you've got a computer. Watch, calculator, phone, computer. Maybe I have a tablet. I don't think we really carry a tablet. But the point is, it's not unheard of to think one person might be carrying around 5 computers, and not be doing anything unusual at that time. So, computing, it was a different world back then. Now, in the 1970s, computing is expensive. There are 2 things that we take for granted now that were big deals then. Number one is data lookup. How long does it actually take to read data from a device and get it back to the screen? So for us, this happens now virtually instantaneously. The second one is network latency. How long does it take to transfer data across the network? I mean, today you go to download a movie and you go, oh my gosh, it's going to take almost a minute to download this thing. And, but we were talking about what does it take to bring information back from a customer's record, across a network wire that might be, if I'm at a branch location for a bank and the main database is somewhere else, it might take 15, 20, 30 seconds to get just that information for the customer record. So we had to think about systems a lot differently than we do today. Another thing that probably wasn't as big of a deal then, but we had to think more about processing power because the ability for these computers to process was a lot more limited. So let's imagine that you're thinking, all right, we're going to use a computer to be able to make deposits. And so we need some kind of screen, design the screen that's going to allow me to make a deposit, to record a deposit. What's it going to look like? It's the 1970s. First of all, there's no mouse. It's all just characters. So, we'll kind of simulate that here in Excel. But what are you going to need? With those constraints, what information are you going to need to be able to record a deposit? Some information won't change. You got to know what. If you're going to deposit some amount, what do you have to know? Okay, so you got to know the amount. So you don't need to do this along with me. This is just kind of visual here. So amount, and I'll just kind of indicate that there's some way that we're, recording that. I'll put a thick border outside. Okay, so we've got amount, and then someone said account number.
What about the currency?
Okay, so it's 1970s. We're probably going to assume this is dollars. So yeah, we're, if it's going to be something besides dollars, go get out of the teller line and go talk to someone who can handle it. Okay, and in truth, this is what it was like. This really is like the entry screen. You're making a deposit, great. We're going to key in the account number, we're going to key in the amount, and we'll hit enter. There's not even a button to click on the screen. We're just going to hit enter when we're done with that. What are the problems? What's the potential problems with this?
Enter the wrong account number.
Okay, the big problem is going to be entering the wrong account number. So, if someone comes in and it's like, I want to deposit $100. Great, deposit, it goes to the wrong account number. Is that a problem?
Yeah.
That's a problem. So, that's something we want to protect against. It's very easy to make a mistake. You key the wrong number. We're going to protect against it. So, what are we going to do? What are your thoughts? Go ahead.
Can you do like a okey-dokey where you have 2 spots?
Oh, okay. So here's another approach would be to say, I didn't understand what you said, a pokey-okey, which I've never heard that expression before, but you're saying enter it twice.
Yeah, and if it's not the same, then it comes up as you put it in wrong.
Okay, so here's the question. The question is, you type it in twice, and then we can just check to see if that is the same. Now, remember the things that we have to guard against are a lot of data access, a lot of data transfer, and a lot of calculation. Does this have a problem with any of those 3? process here. It's all happening right here. You key it in. There's no data transfer. Calculation's absolutely tiny. Well, it's pretty good on those dimensions, but what's the problem with it?
You make the same mistake twice.
That's right. Where does the error happen? Does the error happen as the number comes from the brain to the fingers, or does the error happen as it comes from whatever I'm reading into the brain? If I make the error here, then I'm going to key it the same way both times on purpose. And so I probably am not going to fat finger it twice the same. And so, yeah, this is pretty good. And in fact, if I had two people doing this, if it was like a process that we could like enter it and have, two tellers working on it simultaneously, that's going to be expensive for other reasons. So there's a lot to like about this, but we can do better. Other thoughts?
What about the original information with the account? Like putting the account number and reading the...
Okay. So you're saying plug in the account number and then do a lookup to actually pull back the information for that account and make sure that it's that's Frank. Just go into some account Frank Avignon or something, and we verified that. So that would be pretty good. But what's the problem with this one? Yeah, this is going to take. This is the 1970s when we're just getting started with this. That's going to take too long to bring that data back. So we'd like to, if we can find a better solution, we want to go down that road.
I was just going to say, this might be the data transfer, but if you type in the account number and it brings back the name, then you can compare the name to the ID card that they show you and say, oh yes, this is the right account,
Yep.
and then type in the number.
It's kind of the same idea, and it's a round trip to the database. We'd love to avoid that if we can. If we can't, then okay, line might get kind of long, we have to hire more tellers, but that might work.
So this may be too much in the future, but you could automate the process of putting the account number with like a card or a scanner or a barcode.
Yeah, way too far in the future. But yes, the point is this is human error. If we can find a way to just have the machine read the numbers instead of the human, then that might be better. Yeah. Maybe in the late 80s we could get there, but not in the 70s. Any other thoughts? Yeah.
I mean, putting in a password. That's kind of a dual authentication sort of thing, where you're putting in two fields and you're less likely to get them both wrong. They have to match. So your account number and the user password.
Again, validating that password takes a round trip. But this is interesting. What you just suggested was we had some way that if we made a mistake, we could somehow balance out that mistake and know the mistake had happened. And that's exactly what we came up with. We came up first with the idea called a checksum. Checksum was like this. We said, here's our account number. Let's say the account number is 1, 2, 3, 4, 5.
The amount or the account number?
Thank you. Whoops. Okay. So the account number, let's put $100 in there. Account number is 1, 2, 3, 4, 5. Now, if I just make a mistake on that and put 1, 2, 3, 5, 4, or 1, 2, 3, 4, 6, that's another valid account number. So we got a little bit more sophisticated about how we made our account numbers. So what we said is, look, let's make this account number, instead of 1, 2, 3, 4, 5, let's make it 1, 2, 3, 4, 5, 1, 5. So that's the account number. Now, to identify the account, it still only takes these first 5 numbers. So what's the 1, 5? Where's that 1, 5 come from? It's the sum of all the digits before it. So now, if I type in the account number 1234515, if I make a mistake on this half of it, on the 12345, then if I change this to a 6, if I change this digit right here to a 6, then I can very quickly do a calculation on this, take those last 2 numbers, add up all the first 5 numbers, see if those numbers equal each other. In this case, they won't equal each other. And so this was kind of our first approach to saying, we're going to make it so that if we make a typing error, either when we read it or when we type it out, if we make an error in that, we want to catch it. If I just change any one of these numbers, what's the probability that I'm going to come up with the same result here? 0. I'd have to change 2. I'd have to, not just one mistake, I'd have to have 2 mistakes, and they would have to counterbalance each other. So, well, that's pretty good. The likelihood of getting this wrong is a lot better. But what's the big problem with this one? That's right. The most common problem that we have is a transposition. And so if I take this instead of 1, 2, 4, 5, I do 1, 2, 3, 5, 4, that's going to pass the checksum. That's going to pass the checksum. And so we'd like to come up with a better approach. And so, and look what we did. We came up with the idea of something called a check digit. So the check digit works like this. First of all, for a check digit, it means it's only one. It takes only one character to be able to do it. So we want to put a 9 in here. And now, to make this work, the algorithm has to be a lot more sophisticated about how do we're going to apply some mathematical algorithm to the first part of this number, and then we're going to let that run, and we're going to find out whatever that spits out. We're going to check and see if that's the last digit. And if we can do this, if we can say we want an algorithm that will prevent against any two simultaneous or any two characters next to each other being transposed, and any single character being wrong, and we can check that with just a single digit. It only costs us one extra keystroke every time we enter a number. We say that's pretty good. And so it turns out check digits are everywhere in the numbers that you have, the identifiers that you use. So your bank account has check digits built into it. ISBN. Who's got actually has a book? I was going to bring a book. I forgot to bring the holding features book. Oh, there's an ISBN. Great. So the ISBN on here, 9781119-25906-0. That very last character, that's the check digit. And so what we're going to do today, the example that we're going to do today, is we are going to write a function that we could use right in Excel that would just validate a 10-digit ISBN. You type in the ISBN, and we'll tell you, is that a valid ISBN or not? Well, we won't really be able to tell if it's really an ISBN. We'll be able to tell if it's a well-formed ISBN. If the check digit is the check digit that it should be based on the first 9 characters. In fact, before we're still on this example, one more thing. Have you heard of former BYU professor Frank Abagnale Jr.? Have you heard of him? There's some dispute about whether he ever actually was on the faculty at BYU, but who is he?
He's, well, if you're familiar with the movie Catch Me If You Can, he was the guy portrayed by DiCaprio, and he was essentially a con man that went around and made his living based on pretending to be. Well, it started with forging checks from American Airlines that he posed as a pilot. So
Yeah, Pan Am, actually.
Pan Am,
The book was a lot better than the movie, but yeah, that's right. In fact, in the book, he claims to have actually been on the faculty at BYU. BYU denies this, but I don't know how you don't know really for sure. Yeah, I got a PhD. Great, come teach this class. We need you. So this was actually his very first fraud. He realized that it used to be that when you went to make a deposit, you actually filled out a deposit slip. I went to make a deposit. I don't do this very often. I went to make a deposit the other day. I took a deposit slip out of my checkbook and filled it out. Through the bank, what's this? I don't want this. You keep that. But it used to be, you fill out a deposit slip. And if you didn't have a deposit slip, well, they had a stack of them on the counter at the bank. You just walk up, you pick one up, you fill out your account number and all the information, and they take that slip and they enter the information. Well, he realized that if the account number was written in there, the teller would just key in the account number and move on. If the account number wasn't there, the teller would have to go through a separate process to look up that account number. So they take the information, look it up, there's your account number, okay, great, and we type it in. So he goes into the bank and he takes a stack of these counter deposit slips, takes them home, feeds them into his typewriter, and types in his account number across the top. There's 20 or 30 of them that way. Takes them back to the bank and puts them on the counter at the bank. Edna, comes to deposit her Social Security check, and, she does it exactly the same way she's done it every time. She takes out the counter slip, she writes her name on it, takes it up to the teller. The teller goes, oh, look, account number. Types it in, deposits the money into his account. Everybody's happy. A couple weeks later, he closes the account, takes the cash, and walks away. This was his first financial fraud. He did some other kind of fraud earlier. Anyway, so it's not going to protect. So what we're doing here isn't going to protect against that, but at least we'll be there. All right. So let's take a look at this idea of creating then creating a function. So here I am, book 1, brand new workbook, and I'm going to insert a module, regular old module. Hey, while we're here, let's go ahead and help you get to this option explicit. We talked about what option explicit was. Anyone remember what option explicit does? Yeah, go ahead.
It means all of your variables have to be defined.
Yeah, it's an option telling the interpreter, hey, I'm going to tell you how to behave. The option says you're going to behave a certain way. And the explicit says we're going to require explicit variable declaration. We're going to make two changes. You may already be here, but we're going to make two changes in your editor to make your life a little bit easier. So we're going to come to Tools, Options, and what we're doing here is it's going to change Excel. So your Excel is going to stay this way until you change it. So I'm in the VBA editor. I'm choosing Tools, Options, and we're going to look at these very first two. The first one is auto syntax check. That's checked by default. You should probably uncheck that. It's really annoying when you get halfway through typing a line and you realize, oh, I got to go copy something, and it pops up a dialog box and says, hey, there's a problem. Of course, I'm going to go get the other half of this line. And so that will prevent that from happening. It'll still show the line in red when there's an error, which is okay, but it's not going to display up that really annoying dialog box. And then the second one is the one that will say, hey, anytime we make a new module, put option explicit at the top. All right. So far, every time we've written something in VBA, we started off by saying function. I'm sorry, we started off by saying sub. Today, we're going to start off by saying function. So instead of saying sub, we're going to say function. And then we're going to give it a name. I'm going to call it isValid ISBN 10. And it used to be that ISBNs were 10 digits. Now they are 13 digits. So we're going to do this. And actually, I'm going to leave it for you to implement a very similar function to validate a 13-digit ISBN. In fact, that's your next project. So your next project is to do, it's exactly what we're doing today, except it's a different algorithm. So this will be really helpful. I'll hit enter, and it's going to say, great. Function and function, we're going to do something inside here. All right, so we talked about built-in functions last time we were together. So mid and end string and left and right and replace. All functions. We give it something, it looks at them, and it sends something back to us. And so the thing that a function always has to do is that it has to return a value. Because it's going to return a value, we're going to give it a type to return. Now, if we're just making a variable, dim x, we say as integer. We give it a type right here, or as Boolean. What's Boolean? True or false. And that's actually the kind that we want for this function. This function returns true or false. I'm going to give it an ISBN, well, a candidate ISBN, something I think is an ISBN, and it's going to return true or false. So here's how we specify the return value for a function. We put it right at the end of the function. So just like when we're setting the data type of the variable, just declare the variable and we say as is for a certain type, it's the same thing for when we make a function. Now, this next part's a little bit weird. Here's how we actually tell that function what to return. Somewhere in the function we say, the name of the function, what's the name of this function? Is.isbn 10. We say that equals something. It has to be something that's valid, for the type that we're trying to return. So in this case, it's going to be true or false. That's the basic setup for a function. Now, this function, it's not a very smart function. It always returns true. But we could use this now. We can come to the immediate window. We can say question mark is valid ISBN. Is valid ISBN 10. And it returns true. If we had it return false. The point is we can have some logic that tells it what to return. But right now it's just going to return true. But here's the other thing. Let's go ahead and type in this ISBN number. Here's my little book. Z Systems for Dummies. So I'm going to put this number in right here, which is 970. I need a 10-digit ISBN, so I'll do this one. 119 25906. And that's the 9 digits. So these 9 digits are actually the 9 digits that are the identifier for the book. The The next character then needs to be a check digit. I'm just going to guess 7. I have no idea what the 10-digit ISBN check digit should be. So now here's the idea. I can now use that function that I created just like any old function that's a part of Excel. I can say it equals is valid ISBN 10. And give it something to operate on. Oh, it's not expecting anything to operate on. So I won't put anything on there, and this will then return true. So, first step is for us to say, hey, we need to receive some input to this function. So how do we do that? Now, based on the things that we've learned so far, what do we already know that would be helpful to us in being able to have a value that we can refer to in memory? Yeah, we have a variable. You know, if we could just have a variable that could somehow take this value, that would be perfect. And in fact, that's exactly what we do. So I'm going to declare a variable let's call it candidate, C-A-N-D-I-D-A-T. So this is like my candidate ISBN. I'm going to take that as a string. Why do I want it as a string instead of as some kind of a number? A couple of reasons. Number one, a 10-digit ISBN can start with the number 0. And so if I take it as a number, that number 0 is going to disappear. I will lose that information that there's a 0 in front of it. And second, folks, in fact, almost always ISBNs have some kind of hyphen or period or space in it. We'd like to let those come in, and then we'll deal with them once they get here. Now, this variable that we're going to use is a special kind of variable called a parameter. Parameter is an ordinary variable. It's a variable in every sense of the word variable. It's a location in memory. It has a nickname. We'll put a value to it. We can read a value out of it. The difference is this variable is going to take on its value when the function is called. And so watch this. I'm going to take everything except the keyword dim, and I'm just going to drag it right up between these two parentheses. I don't have to say the keyword dim in here to create this variable because the only thing I can do inside these parentheses is make a variable. I can make multiple variables, but I can't do any arithmetic here. I can't put up a message box or call another function. It's just I can accept the value here. So by declaring my variable inside these parentheses, it creates a parameter. It is a variable, it's a special kind of variable called a parameter. And now this one will take its value when I call the function. And that's what these parentheses are for here. Then at the end, is that I can now give it a value. As a string, I'll put in 1, 2, 3, 4, 5, 6, 7, 8. Now when I run this, you still won't see anything different happen. I'm not doing anything with it, but now that should accept that. It should still execute. If I wanted to, I could do a debug.print just so I can see it happening, the candidate. And so now when I execute this, it's ultimately going to print true because it's returning true, but I've told it on the way to print candidate. And so while it's trying to figure out whether it's true or false, it's going to print candidate, so it should print this number back out here and then print true on this line. So the point is, I'm giving this value when I call the function. That value gets written to the location in memory that has the nickname candidate. And then I can refer to that the same way I refer to any variable. So any questions on this idea of setting up a parameter? We can use parameters both on sub-procedures and on function procedures. It just happens that we're doing it with the function for the first time. Question?
Now that you located, you set up that parameter, can you call it in a different function or a different sub?
Okay, the question is, can I call the parameter? Can I refer to the parameter itself in a different sub? No. It's only going to be available inside this function. But now that we've put that parameter here, if I come back to my Excel, this now is going to be a problem because it's expecting to have a value sent to that. So if I edit this cell and hit enter, it's going to say, yeah, there's a problem. You haven't given me what we need. Well, what do we need? Well, we can just use a cell reference to get that value here. And so now that will be happy again as it is. It's getting the information that it needs to be well formed. All right. So now what we need to do is start to figure out something. Is this candidate a valid ISBN? Here's the first thing I'd like to do. I would like to be able to accept this like with hyphens. In fact, I want to accept it with any non-numeric characters. Hyphens, spaces, dots. Somebody wanted to put capital A in there, I'd be okay with that, but I want to take that as the ISBN. Now, let's take a look at what the rule is, what the algorithm is for calculating that check digit. So to do that, I'm just going to come to ISBN at Wikipedia. And we have all kinds of great information about the ISBN. Ooh, look, there's a picture. How they're issued, different countries get different prefixes, etc., etc., etc. Check digits. Aha! Check digit is a form of redundancy, etc., etc., etc. Here is the algorithm for calculating the ISBN. So here's the number right here. So we've got an ISBN that's right here. There's the first 9 digits of the ISBN. And we're going to calculate what the check digit is. And so here's what it says to do. The text explains you through it. Explains it to you here. Let's just take a look at what it's saying. It's saying, listen, you take 11, and then you subtract this kind of long expression. This says, take the 0. That 0 goes right here. Multiply that first digit times 10. Add that to the product of the second digit times 9. Add that to the product of the third digit times 8. Add that to fourth digit times 7. And so we just move through the digits and we multiply them. The first one by 10, second one by 9, 8, 7, 6, 5, 4, 3, 2. And then we sum them all up together. We then take that mod 11 and then we take it mod 11 again. What's mod?
Remainder.
Yeah, it's like, go back to the 4th grade when you were doing long division. Do you remember this? Some number, you divide it, and that number doesn't quite go in evenly, you end up with a remainder. The remainder is the result of the modulus operation. So if I take 10 mod 7, that's 10 divided by 7. What's the remainder? I take 10 divided by 7. That's 3. So 10 mod 7 is 3. I can do that in Excel. There's a mod function, MOD. I give it the number in the divisor, and it gives me the answer. In VBA, it's not a function. In VBA, it's an operator. So I just say, over here, I will say 10 mod 3, and that gives me, 10 mod 7, and that gives me the result. And so in calculating this, that's what we do. So 11 minus that whole sum thing, mod 11, mod 11. So that's what we're going to have to do. Now, it turns out that for us to be able to calculate this, I think a good first step is to clean off everything that's not a number. Let's look at this and kind of go through it, and let's get rid of everything that's non-numeric. To do that, we're going to do a loop. We look at the schedule, and we don't talk about loops until next week at this time. We've done a lot with loops already. Well, we're doing a little more with loops today. By the time we get to actually doing loops, it's going to be like a great letdown, because there won't be very much more to teach you about. So to do this, I'm going to teach you a new kind of loop that we haven't done much with. I think I showed it to you once, called the for loop. Here's how the for loop works. I say for, I then give it some control variable. I'll just use x. It's going to be some numeric variable. I then give it a range that I want that variable to move across. So in this case, I want to go through all of this candidate. I want to look through every single character in this candidate. And so I want to start at 1 for x equals 1, 2. And so right now, let me just put in a number here. Let me put in 10. Put in 13. because I think I'm actually passing in 13 characters. We'll make this a little more sophisticated here in just a minute. The end of the for next loop is the keyword next. Now, so this loops. If you guess this is going to loop 13 times, you're exactly right, but it does something else magical along the way. And what it does is, I have to declare x here. X has an integer. Lowercase x. Without seeing any additional code here, as I run this, it's going to change the value of x. I don't have to tell it to change. It's going to change the value of x all by itself. So let me just print x. So debug.print x inside of this. And I'll come back up to my immediate window. And I'm going to take the same one that I have. Over. Actually, I'm going to take the one from the Wikipedia page. All right, so now it's going to return true because I haven't given it any logic to do anything besides return true. But what this should do on the way is it should print off just what x is. The first time through this loop, x is going to be 1, so it's going to print 1. So we get to next. Next, we'll change the x to add one more to it. It'll be 2. Take us back up to the top, and we'll now print 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The next will change x to 14, and it's the fact that it went out of bounds that gets us out of the loop. It'll execute while x is 13, but if x gets bigger than 13, when it's starting a new loop, it'll go, yeah, we're done, and we'll exit. So now I'm going to execute that, and it should just spit out all those numbers. There they are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. True. What's the true coming from? I'm printing the result of the function. That's where the true comes from. And then this print is printing the rest of these. So questions on the for next loop? Yep.
How would you make it go back to 1 after it got to 13?
We'll talk about that when we talk about loops. I can show you right now really quickly. You can't make the control variable go one way and then go another way. You get to pick which way to go, but you can make it go backwards. Because you can say, watch this. I can step. If I step 1, that's the default. It will behave exactly as it did. That says, what am I going to add onto x at the end of each loop? But I could step 2. And if I step 2, it's going to do only the odd numbers. If I step 3, it'll do every third number. If I step -1, what's that?
Would it not work? If you go 13 to 1?
Yeah, I have to go backwards to that, so I have to change the index here. In fact, I'm not sure if it's going to print 1 or not. It definitely won't print any more than 1. Yeah, it doesn't even print 1. So I'm going to change this from 13 to 1 and run it again, and now that won't count backwards. So I can make it go backwards, but I've got to make sure my indices are right in the way it's supposed to be. All right. So now here's the trick. For any of these things, this 1 or this 13, they don't have to be constants. They could be some expression that gets evaluated. So what I really want to do is I don't want to go to 13 each time. The whole point is I don't know what the user's going to give me. The user could give me 4 characters. What happens if the user gives me 4 characters and I tell it to look at the 13th character? That's an error. I can't do that. And so I want something that will tell me how long the input is. We have seen how to do this. Do you remember how to do this?
Oh, yeah.
Yeah, len. So I can ask for the length of my candidate. And so now if I put in something longer, 5 more characters on this, that should count up further than 13. If I spelled things correctly. Or at least uniformly. So that counts up to 18 because as this loop starts, it says, hey, where we go? What's our ending number? What's our top index value? Oh, it's whatever the length of the candidate is. It calculates that as 18. It turns out that only gets calculated once in this loop. It doesn't recalculate every time. It calculates at the beginning, it holds that number, and runs through the rest of it. All right, so now what I'd like to do is, I'm going to run this back down 13 digits. I would like to print not just the x, but I also want to print the xth character. So I want to print 1, 0, 2, hyphen, 3, 3, 4, 0. You see it? So what expression can I put here that will do that? Let's not think about the first one, because the first one will make you think left is the way to do it. Let's think about the second one. Let's suppose we're going through this loop. X is now 2, and I want to pull off that hyphen right there. What's it going to take? Mid might be pretty good. Mid. So I'm going to look at something. What am I going to look at? My candidate. I'm going to start where?
X.
Yeah, start the Xth position and return 1 character. And so this is going to say I'm taking something out of the middle of my candidate. I'm going to start at a particular location. I'm going to return a certain number of characters. So it's going to be 1 character. I want to see 1 character at a time. And I'm going to, the first time start at 1, second time start at 2, third time start at 3, and so on. So that was like the trick. The 0, then the dash, then the 3, 306, 0 dash 306 dash 4. Pretty happy with it. Questions? All right. So now is a great time, if your code isn't working, to say, I need a TA. It's a great time. You can pause right now if there's more than 1 or 2 of you. Not right down here in front. Anyone else? Because if you're not running now, it'll be like just kick back and watch, because you won't be able to do anything else.
How do you
Get some
run the
popcorn.
function? How
What's
do you
that?
run the function?
Well, so the way I'm running this function is I have it here in the immediate window. I'm saying I want to print the result of this function. This function is sending the value back. I've got to do something with the value. And I'm just hitting enter on that one. Other questions? You need help here in the front? Yes. You go ahead and pause. It is your job, son, to remind me to re-record. Okay, so now, this is nice because now I have access to each one of these individually. Because we're going to do a little bit of work here, I'm going to write that, instead of just printing it, I'm going to write that into a variable. So let's make another variable here. I'm going to call it 1char as a string. And just for kicks, I'm going to make that a fixed length string. It would work just fine as a string. But remember, string's variable length string. It takes 4 bytes of memory just to keep track of how long it is, and then 1 character for every, or 1 byte for every character that we store. If I tell it right here, hey, this is only ever going to have 1 character in it, then I save those 4 bytes of memory. Big deal. But if we were just to introduce, you could do that if you wanted to. And if you were working with lots and lots and lots of string variables, you might really want to do it. So here's what I'm going to do. To make this code work exactly the same, I'm going to call 1char. I'm going to set 1char equal to my mid expression, and then I'm going to print 1char. So this should behave exactly the same. All I'm doing is I'm just taking my mid here, putting it into the variable, and then printing what's in that variable. I'm doing this because I'm going to do some other calculations with 1char, and the code will be a little bit cleaner if that's just a separate variable. But now that I've made that change, it's a good idea to run that again and make sure that it still behaves the same way.
Can you repeat what the
There's the star one.
yes?
The star one says, hey, I'm declaring a variable. It's going to be a string. But if I just stop there with string, it says that's going to be a variable length string. You can put whatever you want to into it. A lot of characters, a few characters in it will just automatically. But if I tell this, hey, it's going to be exactly 1 character long, then it's a more efficient way to work with memory. And in fact, if it's a normal string, every time I write to it, it actually rewrites it to another location in memory, even if it doesn't need to, even if it's the same size. But if it's a fixed length string, it says, hey, that's the location, and it just stays there. And so it just ends up being a little more efficient. It doesn't have to reallocate memory each time I write. It's going to save us nearly a whole nanosecond by writing this.
So is it okay if we're using string, always put ×1?
Well, no. The question is, so can I always put ×1 for string? And the answer is no, because as soon as I say ×1 on here, that's saying you can only put one character into this string. If I try to put two characters into this string, it's going to overflow. 1 char equals hi. And I will run that. Oh, it didn't overflow, but let's do a debug.print of 1 char here. So the very first thing I'm going to print off 1 char before I even do my numbers. And it's only H. The I just, it can't fit, and so it just says, I guess you didn't need that part. It just goes with what you specified. So you almost always want to use string without this *1. This is probably the only example we'll do the whole semester that makes sense to do a *1 with. And the reason is because we are only ever taking one character. This mid function says bring back one character. That's all we're ever going to put into it. Question?
What's the difference of using string *1 and char?
Char, there's no data type called char. I don't think so. I've never used it. I'm guessing that's going to be a problem. Yeah, doesn't know what char is. Okay. So now here's what I'd like to do. I would like to now look at 1 char and I want to ask, is it numeric? Because if it's a number, it's something I want to keep. If it's not a number, I just want to throw it away. What I want to do is take everything the user gave me, strip out anything that's not a number, and then look at what's left and say, is that a valid ISBN? And so, let's make another variable here. I'll make this one, I'll call this one clean. I'll just call it clean as a string.
Is that a function in VBA?
Is clean a function in VBA? I don't think so. I think that's a valid variable name. You could call it clean candidate or something, but I'm just going to call it clean. If it's it'll tell us if it's a problem. I don't think it is. So here's what I want to do. I've got 1 char in here. I now want to do an if statement. If, again, we haven't formally covered all the different kinds of branching statements we can use. We've seen the if. Let's just take a look at the simple case. If I put some condition, then I put some argument. It's the simplest form of the if. So I put some condition here that evaluates true or false, and then right here on this same line, I tell the one statement that I want it to do. Lots of different variations. So I'm going to say this. If that one character is a number. If that's a number, then what I want to do is I want to accumulate just the numbers into clean. And so here's how there's actually a function for telling us something's a number. It's called isNumeric. So isNumeric, 1 char. Then I'm going to do something. Here's what I'm going to say. I want clean, my variable clean, to be equal to something new. This next part you're going to get really comfortable with in your life of programming. But the first time you see it, it boggles your mind. What is clean the very first time I come into this loop? It's a zero-length string. It's an empty string. Turns out in VBA, nothing is something. It's a specific. It means something very specific. So this is an empty string. And so each time I find a number, I want to take clean and set it equal to what it used to be, concatenated with the character I just found. So I have to think about this as coming through this loop. The first time I through here, x is 1. 1 char is going to equal that 0. If isNumeric 1 char. Is it numeric? Is 0 numeric? It is, so that's true. So we'll execute this number. I'm going to say clean is equal to what it used to be, concatenated with 1 char. It's a little bit hard the first time through because I'm putting a new value in clean. What is it? Well, it's old value. It has to calculate this before it can do the assignment. So whatever it currently is, the first time through, what is clean? It's a zero-length string. I'm going to concatenate onto it 0. What's in clean after I do that operation? Just 0. The next time I hit this statement, it's going to take 0, concatenate clean what's currently there, and I'm going to concatenate onto it the 3. And I'm going to put that into clean. And so it's just going to grow clean by each time and when it finds it. Yep?
So the second time it does it, or once the variable clean has something more than empty, the empty is dropped off.
So the question is, so once we get empty, once it's past empty, does that empty just disappear? And the answer is no, it doesn't disappear. It was never there in the first place. A zero-length string is a string with no characters in it. And so I'm taking no characters, just an empty string, and I'm saying add that onto one character. That's just one character. It's not like there's some other symbol that keeps track of when the string is empty. It's just a character. It's just a string with no characters. Okay. So I've now added clean onto my debug.print. Now it's going to, each time this runs, it's going to be something different. So it should now print, it should print 0 on this one. It should print 0 here because it won't have changed. It should print 0.3 on this one, 0.30, 0.36, and we should see that run. We kind of see it building up the clean version of the ISBN. So by the time we're done, at the end here, we've got just the numeric characters from what was passed in.
Just go to the top of the medium.
So at this point, I feel pretty good about this part of the solution. We've done we've cleaned that number out. We're kind of ready to move on. In fact, I'm probably done printing this out. I mean, as fun as it is to see it do that. I'm just going to comment out this debug.print statement. So, so now I'm probably done looking at candidate because I now have just the numeric version of. Let's have that numeric version. Okay. So now that I have just the numbers, I can check right now. And what's one thing I could check right now and say, oh yeah, absolutely, this cannot be a valid 10-digit ISBN? Okay, if it's more than 10 digits, but or less than 10 digits. Yeah, a valid ISBN, 10-digit ISBN has to have 10 digits. So I'm going to check that right now. Now it's important for me to check this now because once I know that there's 10 digits here, I can just assume, great, there's all 10 digits to work with. I don't have to worry about going out of bounds, looking at it as part of the string that's not there. So I'm going to start right here, and I'm going to say if, help me out here. I want to check to see if this thing is 10 digits long. How do I do it? The length of clean. If the length of clean is, let's do it this way. If it is different from, less than or equal to, that's how we say not equal to, 10, then exit function. Now, exit function just says, oh, I got you here. You said exit function. Get me out of here. Don't run the rest of the code. We're done. In this case, have I ever told this function what to return? No. No. What's it going to return?
True.
Well, let's run it and find out. Right now, it'll return true because I'm giving it 10 digits. So we'll run this. It's running true. But now let me give it something besides. Put another character out here. S. Whoops. Needs to be a number. 3. Now it returns false. The reason it returns false is that every variable type has a default value. When you declare a variable, the VBA interpreter goes out and gets that memory, and then it writes a value to memory at that location. What does it write? It writes whatever the default value is. If it's a string, it writes a zero-like string. If it's a number, it writes a 0. If it's Boolean, it writes false. The default value for Boolean type is false. So if I don't ever tell it to be true, it's going to return false. That's kind of nice here. Because now I can do this check, and I can say, if it doesn't pass this check, just get me out of here. It's going to return false. Okay? All right. Turns out there's kind of a special case we have to deal with here. And that is the possible check digits for a 10-digit ISBN are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. The algorithm can return 10. It's possible for it to return 10. But remember, but 0 is also another possible value, so we can't just use 0 for 10. 0 is 0. So how could I possibly say 10 with one digit? It's possible. How do I do it?
A.
No, that's hex. It's not hex. So it's kind of a good answer. But no. There's another way. You learned it in 3rd grade. What was it? Hex. Roman numerals. In Roman numerals, I can say 10 with one character. Hex. And in fact, that's exactly what the check digit is. So it's possible for a 10-digit ISBN to have its last character of X. If only I had somebody to give you some credit. If somebody could produce a book that has an X as a check digit. You look through your bag anytime you have one. I don't have any credit to give you for it. We could let you substitute a missed class. Go backfill attendance. You would have an X. So it turns out check digits be pretty hard to find. It's got to be an older book because now almost all ISBNs are just 13 digits, and 13-digit ISBNs have they're all numeric check digits. All right, so let's do this. Let's say if the length is different than 10, that means we've got to play with it up here. Let's not worry about that. Let's say we're not going to handle the X right now. We might have to go back and fix it later. But I do want to get through the algorithm that does the calculation. So a little warning, we've got to think about X, and we'll add that at a later time. Okay. So now we've got to implement the algorithm. So the algorithm says we've got to accumulate the first digit times 10, the second digit times 9, the third digit times whatever the next number is, 8. So I'm going to create another variable to keep track of that. Dim, I'm going to call this check sum as an integer. It's an integer plus or minus 32,000. Yeah, I'm not going to get above 32,000 just summing 9 digits. So that should be okay. I'll get by with pipe. All right, so now I'll do another loop. For x equals, this time let's go ahead and go through it backwards. No, let's go through it forward. 2 to 10. Is that how I want to do it? I want to do 10, 9, 8. No, let's do it the other way. Let's do 10 to 2. Step -1. All right, so as I'm trying to make sure that I've got this loop working correctly, I'm going to just print out what I'm after. So debug.print here, x, and now I also want to get at the one character that I'm dealing with. So let's go ahead and use one char again here. So one char should work exactly the same way as it did before. We're just taking one character at a time. Except I take the first character and I multiply it by 10. So
it's going to be with Kanji or with clean?
Oh, thank you, clean. I'm going to print one char. So to see this work, I want to see 10, and then I want to see 0. 9, 3, 8, 0, 7, 6. I want to see that come down. And so I think my 10, 9, 8, 7 is going to work just fine with the x. But now, how am I going to pull that character out? How am I going to get this to say the first time through 1, the next time through 2, the next time through 3, and so forth? Any ideas?
What?
Let's just run this the way it is, and so we can see that it's not doing what we want it to do.
It's still the same.
Oh, I'm not printing.
It's fun because you have
It's a lot of 11 characters.
Oh, thank you. It's 3. That's what I'm for. Okay, so right now I'm getting 10. I'm getting 10, 9, 8, 7, 6, 5, 4, 3, 2 the way I want to see it. But I've got these numbers backwards. Right? It's giving me the 2, and then the 5, and then the 1, and then the 6. 2, 5, 1, 6. I've got to get the 0, 3, 0, 6. So what do I have to do? What's that?
use that. Is the
Oh, so that's there. Yeah, there may be a very different function I can do here, but that's not going to be the easy way. The easy way is to tell it to do something different here. Instead of telling it to do x, I want some expression there that the first time through gives me 1. The second time through gives me 2. The third time through gives me 3. Yep.
11 minus x.
11 minus x. It's 11 minus x, not minus 6. So now, if I run this, it should give me that sequence of numbers that I'm after. 0, 3, 0, 6, or yeah, and it should end on the 5 because we're only doing those first 9. That's pretty good. All right. So now the algorithm says, well, let me just go ahead and multiply these together. X times 1 char. So now I'm getting access to the product here as well. So this should be multiplied across. That looks right. 10 times 0 is 0. 9 times 3 is 27. 8 times 0 is 0. 7 times 6 is 42. But now I've got to add all these up. Any thoughts on this one? Yep.
Can we do checksum equals checksum plus x times 1 char?
Yes, exactly what we're going to do. So let's talk about that. So the first time through, what's the value I have in checksum? It's a numeric variable. It gets initialized to 0 automatically. Checksum is going to equal checksum plus whatever the current product is that I'm working on. So first time through, I'm going to put a new value in a checksum. What's it going to be? The old value, which is 0, plus a new value, which is also 0. Next time through, I'm going to set it equal to what it used to be. It's still 0, plus 27. So my new value in checksum will be 27. The next time through, I'm going to say, oh great, a new value for checksum is going to be its old value, 27, plus 0. Next time through, it'll be its old value, 27, plus 42, and that'll give me another new value, whatever 27 plus 42 is. So let me go ahead and add on here checksum onto my debug.print. So just see if it looks like it's doing what it's supposed to do. 0. First one, the first value is 0. It's adding on to 0. It's still 0. Then the next one's 27. It adds those two together. I get 27. It adds a 0, still 27. Adds a 42. Gets 69. Looks pretty good. And so at the end of this, I've got what I've added on from what I've added up, that first part of the algorithm. I've got this part. All that part right there. So now I'm just ready to do the other two things, which looks like it just says 11 minus whatever that is, mod 11. So I take this whole expression, mod 11, and then I subtract 11 from it, and then I take the whole thing, mod 11 again. So, I don't need to keep checksum around. I can keep using checksum for this. So I'm going to put a new value in checksum. It's going to equal 11. Whoops, it's going to equal That whole thing I calculated mod 11. Checksum mod 11. Then I'm going to take 11 minus that number. Well, then I'll just,
twice.
what's that?
You mod twice.
I think I mod again at the very end. So I take 11. I'm on this step right now here. Taking what I added up, mod 11. I'm going to now subtract 11 from it. Yeah, and then so we can see that whole expression right here. So the last step is mod 11. So checksum is now going to be 11 minus what it was. And I can do it one more time. Checksum, actually the same one. Checksum equals checksum mod 11. And that should give me the check digit that I've calculated. Let me just do a debug.print of checksum at this point. I'm going to comment out the one from my loop because I see that working well. And so, I'm going step by step. We've got this location in memory. It's called checksum. Each step we're just putting a new value in there as we're working up to this value. At this point, we've calculated what the check digit should be. Check digit should be 2. So how do I tell if it's a valid ISBN? I just got to check and see if that is what the very last value is. So I'm going to say if the right of clean, one character, is equal to checksum, then we return true. Otherwise, we never return true. What are we going to return? We don't return true? That should be it except for handling the x, which we're not going to get to. So that's true. If I put in anything else over here, change it to 3, that should return false. 6, going to be false. Put it back to 2, change any one of these other numbers, should be false. And that is now implementing that algorithm with the exception of the x.
Can you scroll down your code a little bit? That's what I'm saying. A little bit more.
Questions?
So for if, we don't always have to put end if.
Yeah, that's right. This is a special case of the if where we only use one statement that executes conditional, and then you can't put end if. We'll talk about the different forms of if coming up. It might even be the next time.
So I guess for the project, we just replace 11 with 13, is that?
So for the project, you've got to, I spell out what the algorithm, it's a very different algorithm.
Oh, it's different?
Yeah. I mean, if this were just change 10 to 13, you're done. That's not much of a project. So yeah, it's really getting a different. But we're going to go over loops. We're going to go over your ifs. We've got more to do. I'm just going to go ahead and plug this particular value into my worksheet, and that should return true. So it should work here as well. If I change this to a 3 on the check digit, that should now return false. Questions? Thanks for coming, folks. Remember, if you got way behind today, I'm going to post this stuff. But if you want to give me some feedback, I'm glad to hear about it. Hey, Sean, you went too slow today, you went too fast. That's helpful too.
Can you check that last part? Can you show that last part?
Yep, class dismissed.
Thank you.